Greetings, everyone. This is Nate's rendition of Assignment 6, Problem 2, where we are given a function f of xy with parameters x and y equal to b, with constraints x squared plus y squared is less than or equal to 1. We are challenged and charged to find a value for b such that the above function is a joint a joint density function. And looking at the diagram, which is somewhat like an ellipsis, it's kind of obvious to see that b is equal to 1 over pi. Now we are requested to evaluate the expected value of the random variable x equal to the two integrals minus infinity to infinity of x, f of x, y, the quantity parameters x and y, dx dy, which is equal to the quantity 1 over pi times the integral from minus 1 to 1 of the quantity x, subquantity of the integral from minus 1 minus x squared to the square root of 1 minus to positive 1 minus x squared of the square root of 1 minus x squared dx, which totals out to 0. Therefore, the expected value of the random variable x given y, 0. The expected value of the random variable x given the random variable y, 0 for these conditional expectations. Symmetrically, because it is x squared and y squared equaling 1, we end up with the expected value of the random variable y equal to 0, and correspondingly the conditional expectations of x and of the variable and the random variable x all equal to 0. Further evaluation, when we lay it out, we see that the expected value of x, y, that's the expected value of x times the expected value of the random variable x times the random variable y, I hope I said that right, is equal to the quantity 1 over pi times the integral minus 1 to 1 of the integral minus the square root of 1 minus x squared to the square root of 1 minus x squared of xy dy dx equal to 1 over pi, the integral from minus 1 to 1 as previously stipulated, but more importantly coming out to 0. This says that the expected value of random variable x times the expected value, the expected value of the random variable x times the random variable y is equal to, when you break apart, the expected value of the random variable x times the expected value of the random variable y. And consequently, they are uncorrelated. And when we do the computation for the fx of x over the corresponding integral, we see that it too breaks down into 2 over pi the square root of 1 minus x squared for all of x less than or equal to 1 and 0 otherwise. Okay.
It's 7:30.
When computing fy of y, it is correspondingly equal to the 2 over pi, the square root of 1 minus y squared for all of absolute value of y less than or equal to 1. Then f of x of the function x is equal to times the fy, the function fy of y. You can see that the computations do not justify their independence. They are not equal. So correspondingly, x and y are not independent. That's the not sign. I apologize for the difficulty, and especially allowing my computer to relate the fact of time.